Okay, this is lesson 1.4. It's just the first part of lesson 1.4. You'll have to watch parts 2 and parts 3 in separate videos for this lesson. So the first thing we're going to do is we're going to talk about something called a radical. A radical is anything that's underneath a root sign. So right here we have 3 perfect examples of radicals. And they're all considered radicals because they're underneath root signs. It doesn't matter what the little index is. It doesn't matter what anything is. As long as there's a root sign like this thing right here, we call that a radical. Now, a radical has different parts to it. And those parts have names. So every radical has something called a radicand. The radicand is what's underneath your radical sign. The radical sign is that actual weird-looking symbol that we draw right there in the green. So our radicand in this question would be 29. And then the next part that you need to know is called your index. The index is the little tiny number that's right above that radical sign. So in this case, your index is the number 3. Now, sometimes you notice that on a radical, such as the one there that I've just drawn on the left-hand side in blue, doesn't have an index. In this one right here, there is no index. If there is no index, then the index equals 2. So that's an important thing to note. If there's no index, it's an invisible 2. If it's not a 2, then it'll always be written in. Awesome. So we now know radicals have radicands, which are numbers underneath the root sign, and they have indexes, which is little tiny numbers that are written. Now what we're going to do is we're going to learn how to take radicals and break them down into different parts. And to be able to do that, we're going to look at examples such as this one right here. And what this page is telling you is that the square root of 16 times 9 can actually be broken up into 2 parts. Those parts are square root of 16 times the square root of 9. And these things are actually equal to each other. This is just one of our radical rules. That you can take a radical, if it's written as multiplication of 2 radicands, it can break up into 2 separate radicals. Again, you can see it here. We show that same example, that you can break this up into the cube root of 27 and the cube root of 8. And now you have 2 separate radicals. Notice that when you break a radical up, the index always stays the same. So the index is the same for both radicals when you break them up. We're going to use this concept and this idea to do something called simplifying radicals. Before we simplify radicals, we will learn a couple more definitions. The definitions are entire radicals and mixed radicals. Entire radicals are radicals where, when you write them, there's nothing in front of the radical. Notice that there's no number in front of any of these radicals here. It's just blank straight in front of it. If there's no number in front, we say that's no coefficient. So a number in front is called a coefficient. In this case, we would say there's no coefficient. A mixed radical is a radical where you do have a coefficient. So you have your radical, but there's something in front of the radical. And you see here we have 3 examples where there's a coefficient of a, meaning that there's an a in front of the radical. In this lesson, we're going to learn how to turn entire radicals into mixed radicals. We call that simplest form. Writing something as a mixed radical is called simplest form. I can't stress that enough. When you write tests and questions and assignments, it's not going to say, write this as a mixed radical. It's going to say, write this in simplest form. Simplest form means mixed radical. Alright, The best way to learn these things is to do some practice. So we're going to practice converting the following to mixed radicals in simplest form. So that's the question. Convert into mixed radicals in simplest form. To do this, we look at question A, and we see we have the square root of 108. That's currently an entire radical because there's no coefficient here. We want to somehow create a coefficient. To create a coefficient, you need to use a special table. The table depends on the index. So if you look at this question, you notice that the index, there is no index. So we say the index is 2. Since the index is 2, you have to look at something called your perfect square chart. And your perfect square chart is just a whole bunch of whole numbers squared. So you see we're going to create it here really quick. This is called your perfect square chart. It won't ever be given to you. You need to know what it is on your own. If you wish to just write these all down and then use it in the future, that's okay. But on a test, you'll have to know how to make that chart on your own. And all I'm doing is putting those in my calculator. 2 squared equals 4. 3 squared equals 9. 4 squared equals 16. Now we've talked about this before, and you notice that all these numbers that I'm circling in blue, they're called perfect square numbers, because if you were to square root them, they'd give you whole numbers. What you need to do is figure out the biggest perfect square number that divides into 108. In our case, 108 can be divided by one of these numbers. And if you start at the very bottom, you go 108 divided by 100, and you go, that doesn't work. And you go 108 divided by 81, and that doesn't work. You go 108, and you're going to work your way all the way up the chart until you get to 108 divided by 36 equals 3. That means we can rewrite 108 as 36 times 3. Those are the same thing. 36 times 3 equals 108. Now that we've rewritten 108 as 36 times 3, what we want to do is break these two things apart. So now we have the square root of 36 times the square root of 3. And remember, that's a rule we learned earlier. It's just a magic math rule we have that radicals can be broken up into two separate radicands. That number 36 that we picked, there's a reason why we picked it, because if you square root 36, it equals 6. The square root of 36 actually equals 6. The square root of 3, you can't simplify that. If you were to put square root of 3 in your calculator, you get something crazy. You get 1.7302. We don't want that. We don't want decimals anymore. We want radicals. All right, we do a couple more examples. So, if we look at B, we have the square root of 50. We want to somehow turn this square root of 50 into a mixed radical, meaning that it has a coefficient. Because right now, this thing doesn't have a coefficient. To do that, we have to find a number on our perfect square chart. So we're looking over here at all these numbers circled, and we're going to find the biggest one of these that divides into 50. And it has to be the biggest one that divides into 50. If you do that and you practice, you find that 50 can be divided by 25. It equals 2. So that means I can rewrite 50 as 25 times 2. That means I can split these because that was our math rule that we learned. If you have a radical that's two things multiplied, you can break it into two separate radicals. The reason we did that is because now you have a perfect square that can be simplified. The square root of 25 is 5. The square root of 2, you can't change that. It's because it becomes a decimal. We don't like decimals. All right, we're going to do another one. But if you look at C, you're going to notice that there's something different about C. You're going to notice that C has a new index. That index equals 3. If the index equals 3, that means you need a whole new chart. You can't use your square chart. You need to use something called your cube chart. And to do your cube chart, you need to write out all your first 10 numbers cubed. Usually your first 10 will be enough. But sometimes you might need a little bit higher number. Sometimes you don't even need that number. Sometimes you only need a few small ones. But what I always do is I write the first 10, right? Because that's always enough. And I'm literally putting these in my calculator to figure out what they're equal to. And the last one. Perfect. Those are called your perfect cubes. I'm going to circle them with a nice green so they stand out. These are your perfect cube numbers. Because my index is 3, I want to find the biggest perfect cube that goes into my Radicand. And in this case, it's 1,000. So I can rewrite this as the cube root of 1,000 times 6. And the reason I'm doing that is because 6,000 divided by 1,000 equals 6. So that means 6,000 can be rewritten as 1,000 times 6. I can split that up. So now I have the cube root of 1,000 and the cube root of 6. The cube root of 1,000 is 10. Whichever number you pick off your perfect cube chart is the number that you should be getting rid of. Again, notice that my index started as a 3 and my index finishes as a 3. That's not a coincidence. Your indexes are always going to be the same, so make sure you don't accidentally change it. Alright, D we're going to do. This little 1 here, that doesn't mean anything. That's a typo. That's just the cube root of 54. So to do the cube root of 54, you need to find the biggest cube that goes into 54. In our case, it's 27. 27 goes in 2 times. So we change that cube root of 54 to be the cube root of 27 times 2. That breaks up to be the cube root of 27 times the cube root of 2. The cube root of 27 is 3. So we have 3 cube root 2. We're going to do E and F together. So we're going to have a couple more questions here. If you look at E, you notice that we actually already have a coefficient. So that might change things a little bit. Because we said mixed radicals are simplest form. But just because it's already a mixed radical doesn't mean we can't make it a more simple radical. So to be in simplest form, you have to have a radicand, so the number underneath the root sign, that can't be divided by any perfect square numbers. It couldn't be broken down further. And in our case here, 192, it actually can be broken down further because 192 can be divided by, 64. So So that means I can rewrite this question as 2 square root 64 times 3. Notice that the 2 is still up front. That 2 hasn't moved anywhere. It's still the number up front. Again, the 2 stays out front. And I break this up into 2 radicals just like I was before. And just like before, I'm going to leave the 2 out front. That square root of 64 is 8. And then we have square root of 3. Now we have 2 separate coefficients. We have a 2 and we have an 8. You need to multiply those numbers together. So 2 times 8 is 16. The root 3 doesn't change. So the question's the exact same. You just leave that coefficient of a 2 to the very last step, and then you multiply it by your other coefficient you got from simplifying. These are the hardest types of questions you get. So I suggest you maybe watch that one again, rewind it, go slow, or watch this last one because it's going to be the same thing. So again, we have a mixed radical, but we want it to be simplest mixed radical. So we leave the coefficient of 3 over 4 out front. That thing we're not going to mess with. And then we're going to rewrite 160 as 16 times 10. Because 16 is a perfect square number that divides to 160. So then you're going to break that up. The 3 over 4 stays the exact same, but the 2 square roots get broken up into 2 separate square roots. We then have 3 over 4 still up front. The square root of 16 is 4. And then the square root of 10 is still right there. Now we have 2 coefficients. We have 3 over 4. We have 4. We need to multiply those together. To do that, in your calculator, you go 3 divided by 4, and you hit enter. And then you go times 4, and you hit enter. And you'll find that it equals 3, and the root 10 is the exact same. So 3 divided by 4 times 4 equals 3. Okay, that's the end of part 1 of this lesson. There's 2 more parts. So you need to go watch both parts 2 and parts 3, and then you're going to have the rest of your class to practice.